Hello everyone, welcome. And today I'm gonna do some work and I'll show you about format string overflow. Okay, so I have already opened that source code. As you can see, it's a protostar format 0 level. Okay, so it's basically a format string overflow. So here is the source code which is written in C program. So I have already written that program, or you can say that I have already solved this. So I just wanted to explain how this exploit work. Okay, how this exploit work inside your Linux system. Basically I am going to done this program on 32-bit. Okay, so let's start. This is my directory, and let me explain you how this format strings overflow occur. What is this? Okay, as you can say, how we can say it is a format string buffer overflow. So let me make a C program. Okay, let me show you. So okay, scanf, sorry. Okay, and now okay, I think it's okay. I'm gonna save this to text. I'm gonna compile this gcc space sample.c hyphen o means output, and our output file will be Alright, and if we execute example, enter the value 45. Okay, it just given as a simply input. Alright, now what format string overflow do? Let back us to our source file, and if we give here another extra format specifier, okay, %x, and I'm gonna save this and recompiling, and I'm gonna execute this example, and I'm giving the value. See what happened, this extra 0 came. Okay, so actually it is a format specifier which I have already given here an extra. So if we change this another, it's already showing up a 0. so basically format string basic overflow is an format specifier so if we examine, okay, so as you can see this, again I'm gonna use this and I'm give another format specifier over here, and again I'm gonna save, recompiling this, and again I'm gonna execute this file. If I give enter, see what's happened out there, it's showing some value. Okay, and if I compile this in to 32-bit, okay, execute this, see what happened, it's showing, actually it's showing some addresses. Alright, it's showing this stack, the value over the stack. So with the help of this we can do some notorious things as we, so let's back to our exploit. Okay, I have already made this. Okay, this is the program. I have already copied down it so that I can save the time. Okay, now back to our work. I'm gonna compile this gcc space -m32 fun oh, squint. Exploit no stack protector. Okay, it's just showing a warning and nothing else, so we can continue with our program. So let's analyze this in GDB. Okay, what sorry exploits. Okay, I'm gonna disassemble main and here is the function check me. So I'm going to disassemble this check me function and let's analyze what's inside this. So I'm gonna give a breakpoint over check me and I'm gonna disassemble check me. Alright, let me so I hope you can see this very well. Actually the terminal size was a bit smaller, so I just maximize this. So okay, these are the these are forming the stacks, EBP, pushing EBP and moving ESP into the EBP and again pushing EBX, and here is setting up the stack 0x32 sorry 34. Actually it's a hex. If we decode this hex into decimal, what we will get 0x34, so 52 means it's taking a size up to from EBP the okay. Actually it's a position of the ESP stack pointer from the base point. Okay, it's calling some functions and again adding, moving, subtracting, pushings, loading, pushings, calling. Okay, so what I'm gonna do is let me explain the code first. Okay, so what I have done, I have created a functions called check me. Okay, and I am taking a target as an volatile integer, and I'm creating a buffer which is holding 40 byte of a space, and I have initialized the target variables as 0 and here whatever I am giving my input into the string, it will transfer into the buffer. Okay, and here is a condition: if target is equal to this date beef, then what we can execute here, we can execute our message. Okay, let me remove this for a while. Okay, we have to execute this message, and this message, when it will execute, if the target variable is equal to this, then it will execute our print message, or if it is not equal to this, our target variable, it will just move out from the program. Okay, so suppose that if we give a breakpoint I have already given over here. Okay, so if I run this program using Python to print our message, into how much, first I'll give 20 times. Okay, and okay, everything is okay. Python. Okay, this run, and I just press C for continuing. If I continue this, exit it normally, and see, there is no message print. Means what happened? If we control O, control X, if we nothing, space, nothing happened, no message shown. Why? Because if we again go back to our program source code, what was this? A 40-byte character. We are to give the maximum length of the buffer size is 40-byte character. Okay, and after giving the input less than 40, it actually did not fulfill this condition. This condition is not matched. Target variable is equal to this value, so that's why the printf message didn't shown. It exited normally. Why? Because I have already given the buffer size 40, and I'm giving my input less than 40. So what if I give my buffer size more than 40? Okay, what will happen and how this format string overflow occur? So after recompiling this again, because I have already made some changes, that's why I have to recompiling. Okay, now again GDB exploits breakpoint on check me. If I give more than 40, the size of the buffer space is maximum is what, 40. Okay, so if I give the input more than 40, then what will happen? So let's check. If I give 55, okay, alright, now let's analyze in GDB. Okay, pushing EBP on stack, NI for the next instructions, and this is the stack pointer, means our stack is at this position. Okay, so moving ESP into EBP, again next instruction, pushing EBX. Now stack pointer creating its space, how much it's creating a space, we have to analyze this. 0x3452, so the space between stack pointer and the BP means base pointer is 52. Okay, next instruction, calling next, adding some value to the EVX. If I analyze the EVX, there is some data moving inside the EVX. Okay, so if you notice this variable EBX minus 0xc is the target variable, which I had, see this target, I have already initialized the target variable as 0, and you can see this 0 is going to initialize this variable. Okay, it's moving means this value is moving into this variable EBP 0xc. Okay, Alright, so let's move further. If we check this print, what was that? EBX or EBP? Let me EBP minus 0xc. Okay, it's 0. Alright, and 0x8, if we analyze this, 0x8 will be 8. Okay, it's 8. So subtracting from extended stack pointer, and again now if we check this x by s $EBP minus 0x34, if we analyze this variable, what will get? We'll get nothing into this. Okay, let me analyze with all form. Okay, it's 0. There is nothing inside this. Again into, now I'm gonna check, because if we see this EBX 0x34 actually, and this capital bracket, this capital bracket means the EBX 0x34 is holding, actually it's pointing to a variable, to a register. Actually it's pointing to the register, it is holding the register's value. Okay, so what I'm gonna analyze the EAX. So okay, EAX have some value. What is this? Gonna analyze this. Okay, examine 100-word hex. Okay, it holds nothing. EX is holding nothing. Pushing EAX. Okay, adding 10 to the stack pointer. Now I'm gonna check this EBP-0xc again. So let me move to an Okay, holding some values. Four one four one means it is holding the value 4141. If we analyze this, examine 10 word hex, see, means our target variable is holding a value of a, and how much it is holding the value of a. If we see this 1 2 3 4 5 6 7 8 10 11 12 13 14 15, it is holding 15 times 15 a 15 times. And if we see into the, and it is moving into the register ex, and if we analyze the ex register, okay, $20 word hex, sorry, okay, actually it sometimes works, sometimes not. What's happening? Okay. Okay, so actually sometimes command work and sometimes don't, so nothing to worry. I have already find it that variable ex is holding 15 times a, and it's comparing to this, so obviously it will, if we execute this, what will happen? Okay, right now our stack pointer is here, ex to this, and it's comparing, and we knew that ex is holding a 15 times, and it's comparing to 15 times a to this value, which is not going to match. So what will happen, it will, here is the condition, if you see that jump if not equal to, where it will gonna jump, it will going to jump on the line 71 here on this place, no operation, and it will just move out. So let's see next instruction. It will going to jump on because our condition is not true, our comparison is not matching with the variable deadbeef. So what is going to happen, you can see it, see our stack pointer has jumped to the line number 71 on this address, no operation. Okay, just simply moving out from the program. Okay, so actually what is happening, I'm gonna tell you in the presentation. Okay, what had happened actually. So here is my presentation. Okay, I'm going to show you what had happened. Okay, first our stack form. Okay, when what happened on stack actually loads the functions variable. Okay, and after that BP form. Okay, this is the BP base pointer, the lowest part of the stack address BP, and the BP always 0. What happened when we give value, sorry, what happened when stack load the functions, stack pointer create an space. Okay, in that case it will create this space according to the variables and the value. So in this case, in this program, stack pointer holding a size of 52 space. Okay, 52 byte space, and on stack here is the our buffer part. Okay, and it's just a simple demonstration. I just wanted to explain how this overflow is working. Okay, so this buffer is holding 40 byte of space. Okay, and stack pointer is holding 52 byte of space. Okay, it assign itself according to the functions and its variables and value. After that, as we know that I have already assigned a variable called target. Okay, and target is 0, and we have to check this condition, target is equal to this deadbeef. Okay, at very starting point target is 0. Okay, and we have to check this condition. So now what happen if we give input more than buffer size or more than too much input, if we give more than size of the buffer. See, this is our input and we are holding our input 55 bytes, what will happen? It will overwrite all the registers over the stack. Okay, see, it's just overwriting over the stack. So in that case, we have to find out the source. We have to find out where the target value variables is holding the position. If we find out the how much target variable is holding byte, then we can easily execute this. So let's back to our GDB. Okay, and again I'm loading our binary file into the GDB, and so we giving breakpoint on check me, and this time I'm gonna again run with the same value. Okay, see, again okay, it loads. Okay, pushing EBX and moving ESP into the EBP, and again pushing EBX, and if we check the value of EBX, it's 0 right now. Okay, forming stack, 52 byte of space, and calling this function. Okay, if we check EBX, okay, well, next instructions. Okay, next, this variable refers to target because we have already initializing 0 value to the target. Okay, moving 0 to EBX 0x3 as we all know. Okay, subtracting 0x from the ESP. If we analyze ESP, so it is holding some address, and I'm gonna examine this value. Okay, it is holding some value. Okay, next instructions, ebp0x10. If we analyze this, print ebp plus 0x8. Okay, we check this, copy. Okay, well, nothing. If you see this address 0xFFFFD3F0 is starting from this. See this? This is actually what A. If we know it is the X value of A 41. Okay. And if we check this $EAX, see $EX is holding our A 55 times. If you remember how much I have given the A, so I actually see I have given the A 55 times. Okay, so the registers EAX is actually holding our input. Okay, and EVP is holding some registers pointing to a registers. Actually it's a pointer. This is a pointer. Okay, this variable is holding some registers address, and if we check this again, EAX, it's nothing, it's blank. Okay, now next, calling printf function as printf function and adding to ESP. If we check this address, examine this, see it is starting from here, D110 actually starting from D110. If we analyze this, copy XYC 34 A 55 times 4 pub. Okay, this 4 byte is actually this one. This hold the value 4, this hold the value P, and this 50 hold the value U, and this 34 is holding the value V. And after that, say A repeating 55 times. If we count this, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26 27 28 29 30 31 32 33 34 35 36 37 38 39 40 41 42 43 44 45 46 47 48 49 50 51 52 53 54 55. Okay, so clear. Now moving to the next instructions. Okay, now EBP hyphen 0xc. The EBP hyphen 0xc is actually our target variable. Okay, and if we analyze, actually it's pointing it's a pointer. EBP 0xc is a pointer. Sorry. Okay, it's holding the value AAA. Okay, check it by another. Let's see, 15 16. Okay, so basically it's 1 byte, 2 byte, 3 byte, 4 5 6 7 8 9 10 11 12 13 14 15. So the register EBP hyphen 0xc is holding 15 bytes of A, and this 15 bytes of A is moving to the register EX. Okay, if we execute this instruction and if we check again, Okay, 41. We check this. Okay, so EX is actually holding 15 times. Okay, actually sometimes the command works and sometimes don't. So we knew that the 15 times A is comparing with this value. Okay, so what we're gonna do is our input is total input is 55. Okay, and the buffer containing 40 bytes, and is the presentation. Our buffer containing 40 bytes, okay, and our input is 55 bytes. Okay, and the target variable is holding this, sorry, this target is holding 15 times A. Okay, target is holding 15 times of A. So what I'm gonna do is I'm gonna subtract. Okay, I'm going to subtract our input. I'm gonna, okay, I'm gonna minus this 55 minus 15. So what the result I am going to get is 40. Okay, so if we give 40 the buffer size, okay, and after that when it will cross it, it will move to the, and rest of the byte will move into the target variable. Okay, what happened? What was happening in the earlier? I'm sorry for the noise. Actually, my son a bit having some health issue. That's why. So, where was I? What was happening earlier? We are giving the input 55 bytes. What was happening? The first 40 byte it was as okay, and after the 40 bytes it was our A is moving, or we can say that overflowing the, not we can say overflow, we can say filling the rest of the registers or variable with A. Okay, after 40 bytes it was okay, and after 40 like 41, 42, 43, 44, 45, it is just filling up the registers, replacing, or we can say overlapping. Okay, So what I'm gonna do, I'm gonna because we have to make this conditions true. Okay, this condition, I have to make this conditions true. Target is equal to 0x dead beep. So what I'm going to do is gonna first queue exploit breakpoint on the same check me. Okay, this time I'm gonna run my program with Python okay. I'm gonna, because target variable is holding 15 bytes of a 15 characters of a, and we are giving the total input is 55. So that's why I have minus our total input from sorry I had minus our target value from the total input, so it will be 40. Okay, plus what was our conditions to make fulfill? Our condition was to this beef dead, actually 0x is a hex. Okay, why I have given this hex? Because in binary, when it loads on the registers, the value get invert, like if we are giving dead beef, and in registers, when it loads on registers inside the CPU, what will happen? The value get reverse, like EF okay, like this. First EB EF, then BE, then AD, then DE. Okay, so what I'm gonna do, I'm gonna write our value in little engine in a hex form. Right? /x means hex, EF /x, BE /x, AD /x, DE. Okay, okay, now okay, without wasting the time, I'm gonna check whether it hit our exact value or not. So I'm gonna give another instructions and another. Now I'm gonna check this EBP-0xc. okay, x by s $EBP-0xc. okay, E by D actually I have what I had given there. What was my input? Well, I have did some wrong. Yes, I actually did somewhere mistake. I'm gonna quit this. I'm gonna again taking a breakpoint and on check me. Gonna run this python space -c print space a into 40 times plus /x ef x. Okay. Hope this time work. This PC program count. Next instruction. Next instruction. Next. 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 Okay. So I'm gonna check. Sorry. Okay, dead beef. Okay, and it's moving into the register E. P is equal to dollar dead beef. Now the condition is fulfilled. Okay, comparing with this, EX is holding this value, and comparing with this, it will now the condition will fulfill. Now our printf function will work. Okay, and this time it will not going to jump on this 72 line because this condition is not fulfilling. Jump if not equal. It will jump because the comparison is equal. EX is equal to this value. Okay, you can see this. See, it will not going to jump on the line 71. Okay, see, it didn't jump. Okay, on line 71. Now I'm gonna continuing this program. See the message print. Okay, so by this we can execute our anything, and we can even execute our shell too. We can get the shell too. We can even execute our systems command inside our program, and we can get the shell. How? Let's see. I'm gonna open this. Sorry. Control X. No. Control X. Okay. What I'm gonna do is just simply we're gonna type this system /bin /sh. Okay, I'm gonna save this. I'm gonna recompile this. Okay, it's a warning, nothing else. And again inside GDB breakpoint, sorry, okay, gonna use this run command. Python space -c printing a into 40 times plus our value. Okay, everything is okay. Python space -c print a x. Okay, running display /10i $c program counter. Next, 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 next. Uh-oh. I've done some mistakes. What I have did mistake. Q exploit check me. Okay, body plus dead biff. Okay, let me check this. Okay, dead biff. Next, comparing with ex. Okay, condition is true. Next instruction, and if we press C, what is this? I get the shell. If we press ID, C, we got the shell 2. Okay, and we can execute our this program by this another way, like exploit space this dollar python space -c space with the same command print space this. Okay, a little bit change over here. What will be the changes is we'll give the format, okay, the byte, the data format specifier. So we'll put over here 7%, and how much byte is 40d, is integer value 40d percent d, 40% 40d means 40 bytes we are printing. Okay, and after that is little engine form. And this, I hope this work. Yes, if we see id, who am I root, now list this ls. Okay, so here we successfully overflow the format specifier. That's it. Thanks for watching. Please like and subscribe my channel, and please support. Okay, I'm just gonna say just support my channel so that I can work on this. If you will won't support the channel, how I could make some video over exploit, over reversing, over any things related to the cyber field. So please support, it will encourage me to make videos. That's it. Thank you everyone. Please like and subscribe and share too.